Module 19.1, Day 1, Central Angles and Inscribed Angles. Content Standard. Identify and describe relationships among inscribed angles, radii, and chords. Language objective. Work with a partner to compare and contrast central angles and inscribed angles. Investigating central angle and inscribed angle. A chord is a segment whose endpoints lie on a circle. So for a chord, it might look like this. So let's say that here is a circle with a center C, so A and B. So then this segment AB is your chord. A central angle is an angle less than 180 degrees whose vertex lies at the center of a circle. So here is an example of a central angle. So here we have a circle with a center called C. So we have a ray called this A, and this is B. So your central angle is angle ACB. Right? And the third one, an inscribed angle, is an angle whose vertex lies on a circle and whose side contain chords of the circle. So this is an inscribed angle. So if we have a circle with the center C, and we have a chord called AB, and another chord BD. So this angle here is your inscribed angle. So angle ABD. Okay. So here are a set of definitions. Right? An arc is a continuous portion of a circle consisting of 2 points called the endpoints of the arc and all the points on the circle between them. A minor arc is an arc whose points are on or in the interior of the corresponding central angle. The measure of a minor arc is equal to the measure of the central angle. So you see that the degree here is the same as the degree here. Right? A major arc is an arc whose points are on or in the exterior of the corresponding central angle. The measure of a major arc is equal to 360 degrees minus the measure of the central angle. So this is our major arc. Remember that for the whole circle, the degree is 360. So if we were to take this out, then they'll give you the degree for the major arc. So then we take 360 minus the minor arc. Right? A semicircle is an arc whose endpoints are the endpoints of the diameter. So this is the diameter, and these are the two endpoints. And a semicircle will go through the center of the circle. The measure of a semicircle is 180 degrees. So that means that the degree from A, BD is 180. Right? Okay. The next definition is an adjacent arc, or arcs of the same circle that intersect in exactly one point. So DE and EF are adjacent arcs. It means that they're next to each other, right? And they share one endpoint. Okay. Arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So the distance from ABD is equal to AD plus BD. Right? So we're using this formula here. Okay, example 1. If the angle BCD is 18 degrees and the measurement of the arc EF is 33 degrees, determine the measurement of the arc ABD using the appropriate theorems and postulate. Line EF and line BE intersect at the point C, so we're given that BCD. So look for BCD is 18 degree, and we're given that the REF is 33 degree. Okay, that means that this angle is also 30 degree, and this angle is also 33 degree by vertical angle. And we are to look for the RABD. So then we see that the measurement of the RABD is equal to the measurement of the RAB plus the measurement of the RBD. So then AB is 33 degree and BD is 18 degrees. So then we take 33 plus 18. So this gives us 51 degree. Right, let's go on to example B. We're given that the JK is 27. So this is 27 degree. That means the angle is also 27 degree. And these two angles are vertical angles, so that's also 27 degree. And so we are to determine the measurement for NP. So we're looking for this measurement here using the approved theorem and postulate. Line MK and line J and NJ intersect at the point C. Well, we're given that this is a right angle, and we know that this line here is a semicircle, so this is 90 degree, and this is also 90 degree. So then we know that the measurement for MP is equal to 90 degree minus 27 degree. So then 90 minus 27 will give us 63 degree. Okay, so they say that for example 3, the minute hand on a clock swept L and R as time moved forward from 3:10 p.m. to 3:30 p.m. What is the measurement of this R? Explain your reason. So then we're looking for the R from here to here, right? Well, we know that for the circle, the degree is 360. You notice that we divide this into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so then we can find out the degree for each of these sectors. So we take 360 divided by 12. So each of these is 30 degrees. So we're looking, so then from here to here, we're looking for this arc here. So there's 1, 2, 3, 4. So there's 4 sections. We take 30 degree times 4. So then it's 120 degree. Right. Okay. So now your turn. Right. So if the REF is 45 degree and the measurement of the angle ACD is 56 degree, determine the measurement for the RBD using the approved theorems and postulate. Lines AE, BF, and DC intersect at the point C. I'll give you a minute to work this out. Okay. Right, let's go on to our next example. Using the inscribed angle. Right? Okay. Inscribed angle theorem. The theorem the measure of an inscribed angle is equal to half the measure of the intersected arc. Okay, so that means that this angle here is 1/2 of the arc AB. Okay, so for example, if we were to have this, and if this is 120 degree, then this angle should be 60 degree. Example 2, use the inscribed angle theorem to find the inscribed angle measures. Determine the measurement for arc DE, arc BD, and the angle DAB and the angle ADE using the appropriate theorem and postulate. So we're given that the arc BE is 18, so then this must be 9, and the angle BAD is 54, so then the arc is twice as much of that. So then this arc here is 100, arc here is 108. Right, so then we're looking for DE, so then we know that from our DE is 108 degree, and we're looking for BD, so then BD is this part here, so then the measurement for the arc BD is 18 degree plus 108, so it would be 126 and then we're looking for the angle DAB, so we're looking for DAB, so this part, so the measurement for angle DAB is equal to 54 degree plus 9 degrees, so it will be 63 degree. And we're also looking for the measurement for the angle ADE. So ADE is this part here. Well, you can notice that this is a semicircle, so this angle is 180 degrees. So this arc is 180 degrees, so this angle here is half of the arc. So you take 180 divided by 2, so it would be 90 degrees. Right, okay, so let's go on to example B. We're given that the find the measurement for the arc WX, arc XZ, the measurement for the angle XWZ, and the measurement for the angle WXZ. Right, so we're given that angle Z is 9 degrees, so then this is 18 degrees for WX, and we're given that the arc from Y to Z is 106, so then the inscribed angle is half of that, so then this is 53 degree, and from there we can solve for the arc WX. So then WX we said it was 18 degree, and the measurement for the arc X and Z. So the X and Z, well, notice that this is a semicircle. So then the arc here is 180 degrees. So then to solve for XZ, we take 180 divided minus 18. So this gives us 162 degrees. And we're looking for the measurement for the angle XWZ. So then the angle X. So we're looking for this angle here, right? Well, we know that this part here from X to Z is 162, so then this angle is half of that, so we take 162 divided by 2 would be 81 degree, and we're also looking for the measurement for WXZ. Where is WXZ? Okay, so let me clean this up. Looking for WXZ is this angle here. Right, so to solve for WXZ, we notice that this is a semicircle. So from here to here is 180 degrees. So then this angle will be half of that. So we take 180 degree divided by 2, so it will be 90 degree. Right? Okay, so now your turn for number 7. So I'll give you a minute to work this out. Okay, let's go on to our next example. Right, so then here refer to the figure for problems 1 through 3. C is the center of a circle, so name a chord. Right, so we could have a chord AB, AE, and we have a special chord AD as well. Right, so you could have a chord AB, AE, and AD. And AD is a special chord, so it happens to be a diameter. Okay, let's go on to number 2. Name a central angle. So we could have BAD. My mistake. A central angle. So let me do that again. So we have BCD and ACB. So we have an angle BCD and angle ACB. And number 3, we're looking for an inscribed angle. So we could have BAD and we could have another one, DAE, and we have another one, ABC. Right? Okay, another triad. For each figure, determine the indicated measure. So here we're looking for the measurement for the arc QS. So we go from Q to S. Well, if this is 47 degree, this is also 47 degree. Right? So QS is 47. Oops, my mistake. Let me do that. So then this is a semicircle, so we don't need to figure it. So QS is just 180 degree. Now we're looking for the RQT. So we're looking for RQT. So in order to do this, we need to follow the order, right? So RQT. So we're looking for the the major arc. Well, then this is a diameter. So this is 180 degree already. So then RQT would be 180 plus 47. So this is 227 degree. Right? And then, okay, let's go to number 5. We're looking for the arc HJ. So then the arc from here to here, HJ. Well, similar to number 4, this is a semicircle. So then the sum, this is 180. We're given that 23, and this is the right angle. So then we take 180 minus 90 and minus 23. So then exchange is 67 degree. Okay. And now we're looking for the arc FEH. So then this is FEH. So this is 180. So then this will be 180 plus 23. Be 203 degree. Right, let's go on to number 6. We're looking for the measurement for the angle CED. So CED, this is 66 degrees, so then CED is half of that, so you do 66 divided by 2, so it'll be 33 degree. And we're looking for the arc DEA. So DEA is here. Well, we're given that this angle is 96, so then this will be 2 times 96 degree. So it'll be 192 degree. Right. Number 7, looking for the angle, for the measurement angle FGI. So FGI is this angle. We're given this is 18, so then this is half of that. So it is 9 degree. And we're looking for the arc GH. So GH is here, so it will be twice as much as 29, so 2 times 39. So it will be 78 degree. Right, so that's the end of our 19.1 Day 1 notes. Your bookwork assignment is number 1 through 15 odds. You have your new HRW and copy down 19.1 Day 2 notes. So this will be 19.1 Day 2.